Today we're beginning chapter 13, which is on personal finance. And in 13.1, we're taking a look at the time value of money. So basically in this section, we're talking about interest earned on money that is deposited or interest paid on money that is borrowed. The amount that we deposit or borrow is called the principal, and it's represented with a capital P. The annual rate of interest is represented with a lowercase r. It's given as a percent in the problem, but it will be expressed as a decimal in the formula that we use below. Time in years is represented by T. So to calculate what we call simple interest, interest is equal to principal times rate times time. And our formula is I equals P times R times T. So let's take a look at example 1. It says a student took out a $3,000 loan for 3 years at a simple interest rate of 6%. So we're looking at the numbers. $3,000 is what is being borrowed, so that is the principal. That's capital P. The 3 years is T, and you can see that placed at the end of the, okay, here's our time. Let me get my ink tool going here. Okay, and then we have 6%. Notice that in the formula, 6% is done as a decimal, 0.06. So remember, you move your decimal 2 places to the left to convert the percent into a decimal. Now, when we talk about future value, we're talking about taking the principal plus the interest. So the future value is the principal plus the interest. And so that actually, and we call this future value, which is represented with an A, principal plus interest. But notice we can write interest as capital P times R times T. Then we'll note that there is a common factor in both terms, and we can factor out the P, and that is what leads us to our formula we have over here on the left. A equals capital P times the quantity 1 plus R times T. So again, A is the future value, P is the principal, and sometimes that's referred to as the present value. And then rate is the annual rate of interest, and T is the time in years. So if we ask what would be the future value on the loan in the above example, it would be $3,000 and $3,540. And so what we're doing is we're taking the principal, the $3,000, okay, times the from the formula, the 1 plus R, again, is represented as a decimal, times the time, which is 3 years. And so we get 3,000 times 1.18. If we take this product, we get 1.18, and we get $3,540. Now, notice you could also get that by taking your $3,000 that is borrowed plus the interest. So that's kind of a way you can double check yourself. We can also get the $3,540 that way. So simple interest, we're talking about the interest being paid at the end of the loan in most cases. Interest being paid at the end of the loan. Okay, so you pay back the principal plus the interest at that time. Now, calculating the future value when we have compound interest. In some accounts, you do have to be concerned about compound interest. And there are a number of ways to compound interest. It can be done monthly, it can be done daily, it can be done annually. Semi-annually is also a possibility. So what we're looking at in this formula is if you deposit P dollars at rate R, and again, R is the annual rate of interest, in decimal form, subject to compound interest paid M times per year for N periods, then the future value of A is given by A equals P times the quantity 1 plus the rate divided by M. So what's happening, M times a year, if it's being done quarterly, you would divide by 4 because that would mean 4 times a year. If it's monthly, M would be 12 because you're paying 12 times a year. So it's taking the annual rate and making it into like the quarterly rate or the monthly rate or the daily rate or whatever. So that's why we're dividing this annual rate here by M. And then we raise it to the number of periods for which the interest is being awarded. So if it's being compounded monthly, and we're talking about 3 years, say like this problem up here, monthly, that's 36. N would be equal to 36. And so that's what we call A is the account's future value. So again, this is future value. P is the present value, or the principal, the how much is deposited, how much is borrowed. Okay, suppose you deposit $500 at 2% interest that is compounded monthly. How much money would you have in the account at the end of 3 years? Okay, and I'm going to tell you a way to enter this into the calculator so that you don't have to do any rounding. Let me talk about that for this one after we go over. Our principal is 500 and the formula has 1 plus. Our annual rate is 2% compounded monthly, so our M is 12, and 3 years, so that's where N is 36. Okay, so that's where our numbers are coming from. 2%, notice it's as a decimal. Monthly gives us the 12, so that's our M. That's our N is the 36. What you want to do on your calculator, got to get mine here so I can see it well. Start with the part in the parentheses. Do 1 plus 0.02 divided by 12, and then hit enter or equals. Now raise that to the 36th power and hit equals, and then do times 500. It's best if you don't round until the very last step, and I'm getting $530, and you want to round it to the nearest cent. Let's see, I'm getting something totally different from what I got when I did this earlier. So maybe I should check my arithmetic again. Did I do 0.02? All right, 1 plus 0.02 divided by 12. We want to hit enter. All right, it looks like I have the same number at that point. We want to raise that to the 36th power and then multiply it by 500. Okay, I've got to make a correction here. Good thing we did this one over. We're getting $530.09. So evidently I made an error when I calculated it for this handout. So you want to make a correction on that one. Okay, so what we're doing is we're taking 1 plus 0.02 divided by 12 equals. Raise that answer, and on some calculators that looks like a caret. The exponent key, raise it to the 36th power, equals, and then times 500, and then you have your answer. That way, if you don't do any rounding in the middle, it won't introduce an error in your answer. And very often students will email me and say, well, my answer is only a penny off or a couple pennies off from what the book has or from what the computer has. You know, why is it counting it wrong? It's because of the fact you did some rounding probably, or you rounded incorrectly. But it's much better not to round until you get to the very last step. So that's a hint for you. Okay, so we have all kinds of ways we can, and all kinds of accounts we can put our money into. And how do we select the best account for our investments? The account that pays the highest effective annual yield is the better one for investment purposes. So the effective annual yield, or the effective rate, is the simple interest rate that would produce the same amount of money in an account at the end of 1 year, when the account is subject to compound interest at the stated rate. And the stated rate, just for your information, is sometimes called the nominal rate. So if we have different accounts, some being compounded monthly, maybe another one being compounded quarterly, another one being compounded daily, and we want to compare those accounts, the best way to do that, to figure out which one is going to produce the most interest, is to take a look at the effective annual yield. And the way we calculate that, we have a formula for that. You'll see this chapter is just full of formulas. So you will want to have your calculator on hand to basically, you've got to plug the numbers in. Just read carefully to make sure you're getting the correct number with the correct variable. And it actually works out to be a pretty easy chapter in most cases. So a nominal interest rate of R compounded M times per year is equivalent to the following effective annual yield. And notice it's represented by a Y. We take 1 plus that nominal rate divided by M. And what was M back here? It was the number of times that it's compounded per year. So that would be 12 if it's monthly. Let me see. M equals 4 if it's quarterly. I'll just abbreviate. M equals 6 if it's done semi-annually. I'm sorry, that would be a 2. Erase that. That should be a 2. If it's done monthly, M would be 12. Okay, so that's the kind of thing we're talking about. How many times a year will it be compounded? And we take 1 plus R divided by M raised to the M power, and then we subtract 1. Don't worry about where the formulas come from. Just be familiar with how to substitute in them. And I'm looking at this last exam is just on this chapter. At this point in time, I'm thinking it may be a computer test that you'll do from home using your book and your notes. So I'm thinking that's probably